Okay, so this is part one of the videos on special right triangles. Okay, so this video is going to cover the 45, 45, 90 special right triangle. Okay, so because we have two congruent angles here, we have an isosceles triangle. Okay, because it's isosceles, we know that both legs have to be congruent. So these are the two legs of the isosceles triangle. They have to have the same measure. These angles are the base angles. They have to have the same measure. So 45, 45, 90 is our special right triangle, okay? Now, because the legs are the same, you can use Pythagorean theorem to prove this, but if I have an isosceles right triangle, the hypotenuse has to be radical 2 times longer than the legs, okay? Always, without fail, okay? So if you know the legs, all you have to do is multiply by radical 2, and that will give you the hypotenuse. If you know the hypotenuse, all you have to do is divide by radical 2, okay? And that'll give you the length of the legs, all right? So let's look at this 45, 45, 90 right triangle, all right? This leg is 2 radical 2. That means this leg has to be 2 radical 2, okay? So since the leg has a length of 2 radical 2, we can find the length of the hypotenuse by multiplying that value by radical 2, just like the ratios up here tell us to. Okay, so we multiply 2 radical 2 times radical 2 to get the hypotenuse. We know when we multiply a radical by itself, okay, we get the value that's underneath there, that radicand. So we've got 2 times 2, which is 4, okay? So if the legs are 2 radical 2, the hypotenuse has to be 4 units long, okay? If I were given that the hypotenuse was 4, I would have divided by radical 2 to get the length of the legs. We've been taught how to rationalize denominators, so when you are dealing with special right triangles, you're going to use that rationalizing step quite a bit, okay? Let's look at example 2. We want to solve for h. Again, we've got a 45, 45, 90 right triangle. The legs are both 9, so in order to find the hypotenuse, we're going to multiply by radical 2. Well, 9 times radical 2, we just mash those together and we get 9 radical 2. We want to leave these in radical form because they're exact, okay? You could approximate this using a calculator, but we want to stick with exact answers when we can. And exact answers are going to have the radical expression in there, okay? Just to reiterate, if you were given the hypotenuse as 9 radical 2 and you were asked to find the legs, you would have just divided this by radical 2, which would have given you 9, okay? Quick little word problem here. High school softball diamond is a square, okay? So it looks like a diamond, but if you were to kind of rotate it a little bit to the right or left, you would see that it's a square, okay? The distance from base to base is 60 feet. So it's a square, so each of these is 60 feet, okay? If I were to draw a diagonal from second base here to home plate here, this diagonal would become the hypotenuse of these two different 45, 45, 90 triangles, okay? So I can use the concept of special right triangles to calculate this distance. Well, square cuts into 42, 45, 45, 90 triangles. 60 feet is the length of the legs. The diagonal is going to be the hypotenuse. So I'm just going to multiply that distance from base to base, 60 feet, times radical 2 to calculate the distance from second base to home, okay? So that exact measurement is going to be 60 radical 2, but in the context of this problem, that doesn't mean a whole lot. I actually need the decimal representation now just to tell a clearer story of this distance from home to second, okay? So using a calculator, I could evaluate this. 60 times radical 2 is about 84.85 feet, okay? And that's how you use special right triangles to solve real-world problems, okay? So this is 45, 45, 90. The next video will cover the 30, 60, 90 triangle.